In this video, we'll do a couple examples with infinite series. So we have determined whether the series is convergent or divergent. If it is convergent, find the sum. Okay, so remember the criteria for converging is that the common ratio is less than 1. So let's look at our sum here. 2 plus 2/5 plus 2 25ths plus 2 1/25ths plus etc. and so forth. So we have the sequence 2 2/5, 2 over 25, 2 over 1/25, etc. and so forth. So that looks to me like we have 2 and then 2 times a fifth, 2 times a fifth squared, 2 times a fifth cubed, etc. and so forth. So I think we can write this particular sequence as b sub n equals 2 times a fifth to the n minus 1. So it looks like our common ratio here, absolute value of a fifth, is in fact less than 1. This checks out. So now recall the formula for an infinite geometric series with absolute value of the common ratio less than 1. That's S equals A over 1 minus R. So now we'll take our information and plug it in here. So S equals, our first term was 2 over 1 minus 1/5. So now this should be 2 over 4/5, which equals 2 times 5 over 4, which equals 10/4, and 5/2. So the sum of the infinite series 2 plus 2/5 plus 2 25ths plus 2 1/25ths is 5/2. That's pretty nice. Let's look at another one. We have 1 plus 7/5 plus 7/5 squared plus 7/5 cubed. Now it looks to me like this particular problem is trying to highlight that our common ratio is 7/5. Now again, the criteria for an infinite geometric series converging is that the absolute value of R is less than 1, and the criteria for an infinite geometric series diverging is the absolute value of R greater than 1. So if we take the absolute value of 7/5, that is in fact greater than 1, which means that this particular sum diverges. So there's no single number that this sum will converge upon. It'll just keep getting bigger and bigger and bigger and bigger. Look at the next one. So let's start by finding the terms of this sequence. So we have E1, 1 over E, 1 over E squared, etc. and so forth. So let's do A sub 2 over A sub 1. That's 1 over E. A sub 3 over A sub 2. That's 1 over E. 1 over E over 1, which is 1 over E. And then to get from 1 over E to 1 over E quantity squared, we have to multiply by 1 over E. So it looks like our R equals 1 over E. Fortunately for us, the absolute value of 1 over E is less than 1, which means that this particular infinite series will converge. So now we can use our formula, which was S equals A over 1 minus R. Go back to blue. So we'll plug in our information. We have E over 1 minus 1 over E. So 1 minus 1 over E, I think, is E over E minus 1 over E, which equals E times E over E minus 1, which equals E squared over E minus 1.